index card yet. We put it in our vocabulary ring. Put an index card dividers. Thank you, Chris. Fantastic. Okay. Did you need an index card, Danielle, or are you good?
Yeah, I
You need one? Anybody else need one? Ivan? Just gonna get suited in now. Okay, so our word, and I'm gonna zoom in on it so you can see it, because we already know how to divide our index cards, right?
Yeah.
Our word today is proportion. So you might remember, way back first quarter, we talked about proportion pretty specifically. But we're gonna come back around to it today and do a little bit of a review. So let's write the word down. Does anybody remember what a proportion is? Anybody think they remember? Okay, so let's help ourselves out. Let me give you the book definition and see if it starts ringing a bell. So the book definition is, a proportion is an equation showing that two ratios are equivalent. An equation showing that two ratios are equivalent. How many of you remember that word ratio? Okay, so maybe it's starting to come back to us a little bit. Why don't I give you some examples of what a proportion is, and maybe your memory will start to get a little clearer. I'm going to wait one more second here, because I've seen a few people curiously writing it down. Maybe longer than 1 second. Okay. Can I go, Joanna? Okay. Yeah? Okay. Danielle, you good?
Yeah.
Okay. All right. So here's two examples of ratios that are in proportion. So the ratio of 1/2 is equivalent to 5/10. So these two ratios make a proportion. The ratio 19/10 is equivalent to 57/30. So these two ratios make a proportion. How do I know that 1/2 is equivalent to 5/10? How do I know that? Anybody, can anyone prove that to us, DJ?
Because 5/10 is, 5 is half of 10.
Oh, 5 is half of 10. So you know that 5/10 is a half. Is there another way you could prove it? DJ's right. What's another way that would work for anything, Chris?
You can divide it by 2.
Divide what by 2? Can you be a little more specific?
5/10.
Okay.
Divide by 2.
Am I going to divide just 5 by 2 or both numbers by 2? Oh, so 5 divided by 2 is 1? You want to rethink?
We multiply by the half.
Oh, so 1 times 5 is 5, 2 times 5 is 10. So we know they're equivalent, they're going that way. Sabrina?
5/10
Uh-huh.
is just like half.
Okay. Half of it. Okay. Levi?
You could divide it by 5.
Oh, so you were going back to what Chris was saying, trying to go backwards. It is division, but not by 2, by 5. 5 divided by 5 is 1, 10 divided by 5 is 2. Good.
You could simplify it by 5.
Simplify it by 5. So you're talking about taking 5/10 and looking at that, knowing that's not in simplest form, and simplifying it and simplify down to a half. Okay, so let's look at some non-examples. So here are some non-examples of proportion. 1/2 is not equivalent to 4/10. So this is not, these two ratios are not a proportion. They don't make a proportion. 19/10 is not equivalent to 57/20. So those two ratios do not make a proportion. We just talked about how we know they're equivalent. How do we know 1/2 is not equivalent to 4/10? How do we know it's not equal? Claire?
Because it's not like, if you're simplifying it, it won't equal.
It won't get down to a half. What's the only way to simplify 4/10? What? Divided by what? By 2, right? 4 divided by 2 is 2, 10 divided by 2 is 5. So it only reduces to 2/5, which isn't a half, is it? Okay, so now for your last piece, remember, in the blank one, how are you going to remember what a proportion is? You go ahead and write down either like a non-linguistic, a picture, or something that, put it in your own words, the definition in your own words. How are you going to remember what a proportion is? DJ, how are you going to remember? Okay, and then these should go on your rings, of course. And you might want to kind of keep them handy today because we are going to be talking about proportional relationships, and the word proportion is in that, right? Okay. So I'd like to direct your attention to our core math idea today. We've talked about proportions before, but proportions are one of those critical things in 7th grade math. So it's always a good idea to kind of come back and think about it again so we don't forget. So today we're going to work on determining whether two quantities, so two different numbers, are in a proportional relationship using a table. So we're being very specific about the tool that we're using today, a table. There's other tools we can use, and we'll talk about them later, but today we're going to focus using a table. So I want to direct your attention to this situation. Is there anybody that's willing to read that situation out loud for everybody? Sina, nice and loud, please. Okay, and you'll see I have a table, right? Okay, and it goes with what Sina just read. So let's first make sure we understand what we're seeing here. What are the two quantities in this situation? Like, what are we comparing in this situation? Levi.
How many ounces and how much money it costs per ounce?
Okay, so we're comparing the ounces of cheese to the cost. So these are what we're comparing. Okay, so that goes, we're trying to figure out whether these two quantities, ounces and cost, are in proportion. Okay? I'm going to tell you right now, they are. Okay? And I'm telling you that because I want you to try and figure out why are they in proportion. Okay? So I want you to think for a minute, and you can kind of talk with your table groups. Can you, from this table, figure out what the cost of 1 ounce of cheese is? Talk with your table. Could you figure out the cost of 1 ounce? Talk with your groups. You don't have to figure it out, but talk about how you would do it.
You could divide.
You know the cost of 5 ounces.
Or we could divide
130 by 5.
Yeah,
And
how
then
much that
the
actually
cost of 1 ounce.
dividing all the numbers of the cost into the ounces.
Or you could do
Oh, so you're noticing the relationship between 5 and 10. Okay.
probably have to divide by 5. Because they're all equal.
Okay. All right. So we're adding. Let's bring it back in 5, 4, 3. Okay, I didn't even just get there. Now I was talking to this table over here, and they couldn't quite figure out how they would figure out 1 ounce. But one thing Sina noticed that I want to kind of point out is, she said, well, I am noticing a relationship between 5 and 10, that it's double. And then the cost also doubles. So she noticed that. Did anybody else notice that? You see that doubling happening there? But then she kind of got thrown off because she said, but I don't understand how the 12 gets there. So that's how it comes back to that cost per 1 ounce. Did anybody at their table groups figure out the cost per 1 ounce, or how to figure it out? Maybe you didn't figure it out, but did you figure out how to do it? What did you think, Javier?
I think that you should divide the cost
Okay.
with the ounces.
All right, let's try it. So let's take this first one for a minute. We're going to do $1.20. We know that costs 5 ounces, so we're going to divide it out, right? Mm-hmm. Well, does 5 go into 1?
No.
Does 5 go into 12?
Yeah.
How many times? 2 times. Then I get 10. 4. So what's the cost per ounce?
24 cents.
Okay, so I can say that 1 ounce, I'm gonna kind of squeeze it in here, is 0.24, right? 24 cents. Can I prove it another way? If this is the cost per ounce, what should happen here? What do you mean? How should it stay the same?
Because it's kind of doubles,
Okay.
it should like, in bottles of those, it should like stay same.
Okay, so you're saying if we're doubling the ounces and the cost, then if I divide this out, should I get the same unit rate? Let's try it. Let's see if Levi's right. So let's take 240 and divide it by 10. Because he's saying there's a relationship here, right, that Sina pointed out. So he's saying that relationship tells me that I should still get the same unit rate. 10 going to 2?
No.
10 going to 24?
2 times.
2 times. That's 20.
4.
4. Oh my gosh. He was right. Now, how could we prove then? Remember, let's go back to what Sina said. She said, I see the relationship here. It's double. But she's like, I couldn't figure out the 12. How does that fit in? Can we prove that this 12 to 288 is proportional to the rest of these? How could we prove it?
Am I doing the same way?
Let's try it. 288 divided by 12. 12 going to 2? No. 12 going to 24?
28.
Or 28, yeah. 2 times, that is 24. Thank you. Almost gave it away.
4 times.
Oh my gosh. What do you think is going to happen to this one?
The same thing.
When we divide it out, we're going to get to 24. So, how am I going to tell if I'm given a table of values if they're in proportion? How do you think I'm going to tell? Remember, I told you these are. What did we do to prove that they're in proportion? Abigail? You divide each ratio, right? If each ratio equals the same thing, what does that tell us?
That's
That it's proportional, because they all simplify down to the unit rate. Okay? Does that make sense? So, we're going to practice this. You guys want to practice it a little bit? You can kind of do it on your own. I've got a bunch of situations. Okay? Not a bunch. That kind of 6 situations, okay? And you're going to get to see them in a minute up close. But I'm going to kind of put them up here so you can kind of get an idea. We're going to look at a situation about driving. We're going to look at a situation about cell phones. We're going to look at a situation about a map. We're going to look at a situation about a toaster. I'm going to cover up our core math idea right now, but we'll come back to it. We're going to look at a situation about a smoothie. And then our last situation is going to be about the internet. Okay? And your job with your partner is going to be to determine, is this situation proportional or not? By looking at the table. So let's remind ourselves again, how are you and your partner going to decide if the situation is proportional? What are you going to have to do with those numbers in the table? Levi? You have to divide them out and see if they all get to that unit rate, right? That same unit rate, okay? So in a minute, you and your partner are going to get a stack of cards that have these same situations on them, okay? You're going to have to sort them. Proportional, not proportional, based on what you figure out about the table. Now here's the biggest key. Do I ever let you just tell me an answer? No. What do I always ask you to do? Show your work and explain, justify, right? So you're also going to get a little note taker, okay? Where you can kind of do your division to see if there's equivalent ratios. Then tell me if it's proportional or not, and then tell me why. Why did you decide yes or no? Does that make sense? You can work in any order you want. You don't have to work straight down, straight down. You can skip around. Maybe somebody really wants to talk about the cell phone one, so start with that one. I don't care, okay? You're gonna have about 15 minutes to work with your partners and try and get through as many as you can and decide if they're proportional or not. Does that make sense? Okay, so can I have 2 volunteers? Oh, by the way, before I say that, you're gonna work with the person sitting across from you. Okay, so move down. Cheyenne, can you move down and work with Griffin, please? Okay? And I think everyone else has somebody across from them, yeah? Yeah. Okay. You're gonna work with the person across from you, and you can work together. I want you each to fill out your own sheet, because this is kind of your note taker, so I want you all to have a copy of that. You're only gonna get 1 copy of this. Let me go and pick up one. Okay, one packet to each partner. Who else? Okay, 1 to each person. Okay? Now I'll be coming around to check in with you. Okay. Griffin, you're going home, so you need to go to the office. So then you 3, Jalissa, Griffin, or Jalissa 1, and Cheyenne work as a group of 3, okay? So they only need 1 now. Okay? So you're gonna work as a group of 3 now, so they only need 1. Okay, so you've got the cards that you can look at. They're also on your paper, so lots of places you can find those tables. Yeah, you're working with the person across from you. Maybe she needs it, because she has a partner. Jasmine's just passing out. All right, thank you,
It's just adding 50 by
Okay, but how are we going to prove if it's in proportion or not?
Proportional because
I mean, I heard you say it's just adding 60 every time, but does that prove it's proportional? How do we prove it's proportional?
20 times 2.
You have to divide.
Okay, so you need to divide the ratios and see if they all get the same. Add it.
Is this one 60? Where is it though?
So maybe something that you could do is you just said 60 divided by 1 is obviously 60. So let's write that underneath. What did you get when you divided by 60 again? Okay, so see what you get each time and see if they match. So how many times is 1 to 12?
That's 6.
Right? Oh, that's 2.
That's 2.
How many times is 2 going to 0? 0, right? So what did you get when you divided? 60. So keep going. Do you get 60 every time? If so, what does that tell you? Okay, what would you do?
It's proportional because it's obviously 60. I said 62.
Okay, but is that how we prove it's proportional? How did we talk about we prove it's proportional in our primary session before we started? Yeah, so all of them divide out to the same thing.
24 6
It looks like you
times
were kind of checking it. Okay, good.
0, bring that 0 up. That's 62. I'll just have to check 300. Divided by 5.
Okay, you guys started with the smoothie. So, how are you guys going to figure out if it's proportional or not?
They're all 60. Yeah, so it's proportional.
1. Okay.
So we turned by 1 and 2.
And you got 3. So now you got to do the same thing to the next one, right? And see if you get. All right, awesome. So you guys are starting with the cell phone? Oh, driving. Okay. So I want to talk to you then about the cell phone one. What are you going to do?
When you multiply the
When you divide it, all equals 60.
and
This is proportional.
The cell phone one.
So 30 and 35 divided by 1, right?
Because
Cell phone company charges 30 per month plus 35 per minute.
So this first one is 35. So now you gotta check and see if that one is 35, right?
2 times what equals
How are we doing over here? Any questions?
12.
Do you think this one's in proportion? Not sure yet? What do I do?
The fifth month.
No, why
And
not?
then
Can you explain to me why it's not?
it's 35 cents per minute. So
Oh, interesting. So
I just do the same thing as the other one. Like,
so we have to divide 33 with 50 cents.
they don't, so that tells us it's not proportional. Figure out why. What's different about this one and try explaining why it's proportional and then you compare.
divide by 2.
What do you guys notice about the driving
So maybe we should divide them
Oh, so are they all, what are they all gonna divide out to then? 60, so you all have the 8, right? You guys figure out the driving one? Mm-hmm. Okay, and which one now? Cell phone. What do you notice about cell phone?
35 cents.
Then it all should equal, or right now, it all should equal like $3.35.
So you gotta figure out if they do. Keep going. Which one are you guys gonna work on now?
37.
Oh, so you're working in order. You're an order kind of guy, huh? Some people are skipping around, but a lot of people like to order. Yeah.
Because
What did you get? 30
I got $3.35. Well, I divided
So when you divide this one, you got
$3.50.
$3.35, right? So now you want to check this one. When you divide this one, if you get the same thing, what does that tell you? And if you get something different, it's not. Yeah.
Okay, so then all of them should equal $3.
Oh, the toaster one. Is this? Why? Can you tell me what it is? Right, but look at the division. 1.5 divided by 1 is 1.5, right? Is 1.5 divided by 2?
60.
Yeah.
Are you gonna get the same thing when you divide it every time? No.
It's 2 times
What does that tell you then?
60.
What does it tell you then? It's not proportional because I look at this, I see something kind of weird when the slices go up, like when I look on slices, it stays the same. And then the slice goes up, then it goes up, and then the slices go up and then it stays the same.
That's 100.
Do you see that? It's kind of a weird pattern.
Oh, wait.
Wait, what?
If it's around 7, yeah, because it's 140.
Slots for bread. It takes 1.5 minutes.
Yeah, I was on.
No, it goes in.
It goes in 7
Stays in 7 minutes.
It goes in 7 times.
Jumps. Stays in 7 minutes and it jumps. How many slices of toast can you make it? 2. So if I put in 1 slice, it's going to take 1.5 minutes. But I could put 1 in each slot, and it's still going to take 1.5 minutes. You see that? So then, is it proportional? No, it's not, because you're doing 2 at a time. See that? Okay. Ooh, we got the map one. What'd you guys get for, what were we working on before? Oh, you always got 3. Yeah, which makes sense because what did it say? How many bananas do you need to, or how many bananas do you need to make 3 smoothies?
Scan your face and they can figure out your name.
Right? What did it say in the beginning? To make 3 smoothies, you need 1 banana, right? So it should always come out to 3. Okay, cool. All right, so keep working on the math one. How are we doing over here? It is proportional. Not proportional. Why not? So when you divided them out to find the unit rate, it wasn't the same. Why do you think that is? You're right, but why do you think that's happening? What's special about this situation?
Why I don't like you either.
Well, right. But what makes this one different than this one? Like, why do you think when you divide this one out, you get different answers, and when you divided this one out, you get the same answer? True.
3.35. This is not true.
But I'm just talking about in general.
10.35.
Yeah. So, in general, what's different between this table and this table? Is there anything that's totally different?
When you multiply,
Oh, I see. It says costs are
you
here.
were supposed to write down why.
$30 and it has no minutes on it.
Oh, and what about, why is that different than up here?
Because this one has miles, has nothing, and hours and nothing. It's all zero.
Right, exactly. So this $30 for no minutes kind of throws everything off. You're going to pay $30 no matter what. Yeah, and that throws it all off. That makes it not proportional. I definitely want you to share that when I come back to it, okay?
We found out that the cell phone's not proportional.
Why?
Because every time we kept on dividing, we had different answers.
Why do you, okay, you're right. So you divided them out, you got a different unit rate every time. But why do you think that's happening? What's so weird about this chart that's making that happen?
The numbers are lower. No, like the minutes.
Shouldn't it matter though? I mean, because we're talking about a different situation. But this chart you said is proportional, right? This one you said isn't. And this one when you divided, you got the same unit rate. This one when you divided, you got a different unit rate every time. But what's different about these two charts that's making that happen? Look at them
This
really
one's like
closely.
even.
But I could make this one even. I could go 1, 2, 3, 4. I could. But still, when you divide it out, you still get different answers. So think about that a little bit. What's the difference there?
There's 5.
One
So
second.
it's 5 over 4.
Yeah.
And then we have to divide but since it's fractions, we just basically flip the second number and multiply, which you can't because it's. You can't flip it. Oh, yeah. Yes, you can because it's 150 over 1. 150 over 1, and then you have to flip it. So then it means.
Okay, so let's think back to what we were doing with the sheets. How
Then you
were
have
we
to
proving
multiply it.
that it was proportional? What were we doing to the ratios in the chart? Dividing. So let's try that instead. So 30 divided by 0 is 0. $30.35 divided by 1 is $30.35. What's $33.50 divided by 10?
Yeah, 600. 600. Okay. So then what do we do then after that? Then do you know how to turn it into decimals and numbers?
But this is the minute.
$3.35.
Over
So
5.
when we are dividing, are we getting the same unit rate?
Yeah, let's just go to the next one.
We are? These are all the same?
We'll go back to that later.
So right away we know it's not proportional. So now the question is, why is that happening? Why do you think that's happening? Why, when we're dividing out, are we getting all different numbers? Why is it not proportional? There's something happening in this table that's not happening up in this one.
It goes 0, 1, and then it goes all the way to 10. 10.
I could have done that in this table though. I could have put 10 on here, and then I would have known it would be 600, because 10 times 60 is 600.
Since it's
So,
It is, but there's still something else. Maggie's gonna bring it up, but kind of look at it, compare these two. What are you seeing that's different between that proportional one and the non-proportional one? Did you have another question?
no.
Okay, because you had your hand up. Did you have a question? Okay. Okay. let's do the division. So let's divide. So we've got 1 divided by 1/3, right? Okay, so 3 divided by 1 was what? What's 3 divided by 1? 3. What's 6 divided by 2? Divided by? How many times does 2 go into 6? How many groups of 2 can you? 3. What about 3 into 9? Okay, so we're looking at 3. We want to see if this one gets us 3, right? So we want to see if, how many times 1/3 goes into 1. So 1, can I write that as 3 over 3? Okay. How do I do division of fractions? What do I have to do? Okay. Which is what? You got it right here.
You can choose it.
3. Oh, so it does get me 3 when I divide. Yeah. It's proportional, huh? The unit, what's the unit rate? Great, yeah. Yes. Okay, why? Well, how did we figure out how to do, what did we talk about with the cheese? When it came to deciding if it was proportional, what did we have to do to these ratios?
We haven't
Divide
found
them to see if they came out to the same answer, same unit rate. So you have to do 150 divided by 1 1/4, 300 divided by 2 1/2. See if you get the same answer every time. Okay, how do you divide fractions? So it's kind of going back to, so we have 150. Remember, first thing, we change this to what kind of a fraction?
The second was 60 as well.
Which we now call fractions greater than 1, right? 4 times 1 is 4, plus 1 is 5, so divided by 5/4. Can I write this as 150 over 1? Now how do we divide fractions? What do I have to do to this? Right, and then this, you flip it over, so now straight across. Okay. Okay. I'm going to give you guys about 1 more minute, so try and finish up the one you're working on, and we're going to come back together. What are you guys thinking about that toaster? That's a weird one, huh? Not proportional. Why? You just kind of shot that out at me. Why?
It's in a pattern. It's 1 and 1/2, 1 and 1/2, 3, 3, 4 and 4/2, 4 and 4/2.
Okay, so why does that tell you, that pattern tell you it's not proportional?
Because if it's 3, and then if you go,
Well, we can't
if
even
it's
start
3
it
right now, and if you go to 4, you shouldn't be 3. You should be like.
So you're saying there's no way these can be equivalent because you changed the number of slices, but you haven't changed the minutes, so there's no way it can be equivalent. Okay, good point. I like it. So you almost didn't even need to divide. You saw right away. There's no possible way that's possible. Okay, love it. Okay. All right, ladies and gentlemen, we are going to bring it back together in 5, 4, 3, 2, 1. Okay, so even if you're not finished, that's okay. Hopefully we had people working on enough of them at different, I told you could jump around, that we'll have some people be able to share their thinking, okay? And then if you didn't get to that one, you can write down, okay? So, for example here, I'm noticing Karina didn't get to the back side, which is fine, okay? But when we talk about the toaster one whole group, she's gonna take notes on that, okay? So you're gonna take notes. And what about if maybe you said it was proportional and we figure out it's not, or what if you got it wrong? What are you gonna do? Take your notes, or erase, or cross out, okay? These are just our notes. We're just practicing right now. It's okay if you made some mistakes. Just make the changes. Okay, so let's start with this driving one. I noticed a lot of people started with Lightning McQueen here, okay? What did you guys think? Was it proportional or not, and how did you know? Who can tell me? Proportional or not, how do we know? Okay? Let's start with Jasmine. What do you think?
I thought it was proportional because if you times it by each number by 60, it would come out the same.
So you're saying, so 1 times 60 got you the 60? 2 times 60 got you the 120?
Yeah.
3 times 60 got you the 180? And so on? Okay, so from there, Jasmine, were you able to figure out what the unit rate was then? What is the unit rate? 60 miles per
Hour.
Okay, so she's saying the unit rate was 60 miles per hour, okay? So she figured out all of these get her 60 miles per hour. So she's saying it's proportional. How many people agreed? I agree too. She had good reasoning why, so it's proportional. Okay? Because she found the unit rate was 60 miles per hour every time, right? Every ratio. Okay, what about the cell phone? That was an interesting one. Maggie, I want you to talk about this one because you came up with something pretty important. So first of all, tell us what you thought. Not proportional or proportional? Not proportional. How many people that worked on the cell phone agree this is not proportional? I agree too. So we're going to definitely say it's not proportional. Now, I'm first going to have Maggie talk about how did you first decide it was not proportional? What did you do?
Well, we were dividing.
Okay, so you started dividing. So 30 divided by 0, that's 0, right?
Yeah.
Then our next one was 35 divided by 1 minute, that's 35. Those are kind of easy division ones, right? Then did you keep going to the 10? 3350 divided by 10, what did you get then?
We got 3350.
No,
No, that answer.
you didn't get 3350. Serena's helping her out, give her a minute. I think she just looked at the wrong one. Brandon, help out your partner. What did you guys get when you divided 3350 by 10?
$3.35.
$3.35.
Yeah, that one.
Okay? So, Maggie, what made you guys decide based on your division that it wasn't proportional?
We keep getting different answers.
Okay, you kept getting different answers when you divided, so they weren't all dividing to that same unit rate, right? So we know they're not proportional. Well, then I was talking to Brandon and Maggie and I said, why do you guys think that's happening? And they had happened to do the driving one first. So I said, look at the two tables. So I want everyone, look at the cell phone table and the driving table. They're right on top of each other, right?
Yeah.
Maggie, can you explain what you guys figured out? What did you notice was different?
Well, I noticed that the driving one, it has the miles 0 and the hours 0.
So she was noticing that 0 miles was 0 hours in a proportional relationship. And then what did you notice?
I noticed that in cost, you have $30 and without no minutes.
And then she noticed in this non-proportional relationship, it wasn't 0, 0. It was 30, 0. So what did we decide? What was making it not proportional?
Because you're paying $30 that you don't even use the minutes.
Yeah, you're paying $30 no matter what. That $30 for no minutes was throwing it all off, wasn't it? So that was why we kept getting different answers when we divided. Okay? So think about that. What does that tell you about when we get to properties of when things are in proportion? Kind of keep that in the back of your head. Okay? What about the math? The math was a tough one because there was a lot of fractions and fractions are hard to work with. What did you get, Javier?
It's not proportional
You don't think it is? Why not?
because after I kept on doing my math, I kept on getting different answers and
Okay, so when you divided 1 1/4 or 150 by 1 1/4, what did you get?
1.25.
1.25. Did anybody else get that? Did anybody else do the division? No? Okay, let's do it together for a minute, okay? So we're gonna take 150 and we're gonna divide it by 1 1/4. I know, your favorite thing, fractions, right? How do we divide them? What can I do? Let's make it kind of quick. Brandy?
You need to mix number.
Okay. Well, this is the mixed number, so make it a fraction greater than 1, okay? So I'm going to do 150 over 1 divided by, what's that going to be?
5 over 4.
5 over 4. And then how do we do it?
You copy 150 and 1, and then you make into a
Okay, so now you have 150 times 4 is 600, right?
Yeah.
Okay, so that's 600 over 5, which is how much? How many times is 5 going to 600? Well, how many times is 5 going to 60?
12?
12, right?
1,200.
No, just 1 0. Yeah, because it goes into 60, 12, and then the extra 0. So we got 120 here, okay? What about 600 divided by 5
We just got
is 120. We just got that one, so that one's the same. 300 divided by 2.5. What are we thinking? So I'm going to kind of squeeze it in here. 300 over 1 divided by 2.5 is really 5 halves, right? So that's 2/5. So I get 600 over 5 again. What am I getting every time?
120.
120. So what does that tell me?
It's proportional.
It is actually proportional, okay? So, Javier, what do you think happened?
After I got my new fraction for 1 over 1/4, I had to divide it 4 over 5.
Okay, and you so maybe you kind of messed up in the calculation a little bit, but you had the right idea. You knew you had to divide to see if all the ratios got the unit rate. Okay, toaster. DJ, I want you to talk about toaster. Because DJ took one look at it and he says to me, what'd you say to me?
it's not proportional.
Yeah, he took one look at it and he said, I don't need to do anything. I know it's not proportional. Why? Can you explain? What did you talk about?
Because 1 on the minutes it's 1 over 1/2. Over 1.
So one slice takes 1.5 minutes.
1 and 2 takes 1.5, but they're not it's not supposed to be like that. 2,
Uh-huh.
the numbers are completely different. They're not the same.
So he's saying if it's 1 to 1.5, there is no way that that ratio is the same as 2 to 1.5 because the top number changed, the bottom number has to change in order for those ratios to be equivalent. So he knew right away these are not equivalent ratios. There's no possible way. Because something changed for the slices, but nothing changed on the minutes. So he was noticing for sure that these two, not equal. These two, not equal. These two, not equal. There was no way because the minutes weren't changing. So if they're not equal, they can't be proportional. Smoothie. Pedro. It is proportional. Why? Proportional because they all divide to be what? 3, yeah. 1 divided by 1/3. How many 1/3 can you fit into one whole? 3, right? A third, a third, a third, that's 3/3. Okay? 2 divided by 2/3, 3 divided by 1, 6 divided by 2, continue on. It's always 3, 3, 3, 3, 3, okay? So he says it's proportional. Internet. Anybody get to the internet one? Okay, the internet one, look at it on your paper. It's really similar to the cell phone one. Tony, what are you thinking? Why? Okay. Okay, so say that one more time. 30.25 divided by 1 is 30.25. So 51.25 divided by 5 is what?
Is 7.0.
Okay, so you notice the division is wrong, right? You're not getting a unit rate every time. Why is that happening? Think back to what Maggie said. What's so special about the internet? Why is it happening? Why are you not getting the same thing, Brandy?
Because on the cost, it has 25 and the hours are 0.
Yeah, there's not that 0 part again, right? Okay, so we're gonna wrap things up here, ladies and gentlemen. I'm going to go ahead and pull down all of the non-proportional ones. Okay? And I want us to really look at the proportional ones to come up with some properties of direct proportion. What are some things we know about tables? What has to be true about a table of values to tell us it's in proportion? So look at your tables that were proportional, okay? What has to be true about that table of values for that situation or those two quantities to be proportional? What are we thinking here, Sabrina?
Well, numbers have to keep changing.
Okay, can you be a little bit more specific?
Well, like, the numbers they have to keep changing, because, like...
Or are you thinking about the toaster one?
Yeah.
Okay.
Like, these ones, they don't change, so...
Okay, so if one quantity changes, the other one has to change.
Yeah.
Okay. If one quantity changes, the other one has to change. So she's going back to that, what DJ had said about the toaster. How one changed but the other one didn't, so there's no way they're proportional. What else? Maggie?
About the zeros.
Oh, the zeros. So if one quantity is 0, the other quantity is 0. Oop, is 0. The other quantity has to be 0. What else, Brandy?
It has the number that you the two numbers that you multiply have to
You divide?
divide
Okay.
have to be all the same.
So all the ratios have to divide to the what?
Same number.
The same number, or the unit rate, right? So all the ratios have to be equivalent, really, be equal. And how do we know they're equal? Because they divide to the same number. Okay, Levi, what are you thinking? Okay. Cell phone?
Cell phone one.
Yeah.
And I noticed that, like, for the cost,
Yeah.
like, for one's 0, one's 25,
Yeah.
with all the other ones to the right,
Yeah.
it's all decimals.
Okay, that is true. However, that's not necessarily doesn't mean it's not proportional. We can have, because can't fractions, we could write this as 1.25, and this is proportional. So the decimal thing, that just happened to be a coincidence in this case. Okay? All right, ladies and gentlemen, what I need you to do. First of all, are we able to determine if quantities are proportional using a table? Yeah, we reached our goal, didn't we?
Yeah.
So what I'd like you to do, put those cards back in the pile. Everything else, like your notes, go in your folder.